Hello, and welcome back to another IB Math speedrun with me, Vince. In this speedrun, we're going to be going over integration by substitution, so let's jump right in. So, yes, we can usually do integration by inspection or use reverse chain rule, but sometimes it's a bit too hard to do that. So let's look for a suitable function like 5x minus 4 to the 7. Yes, we could reverse chain rule it, but it might be too hard, and that's why we can use integration by substitution. Actually, that's a bit large. Make it smaller. Anyways, the integral of 5x to the minus 4 to the 7. So how integration substitution by works is similar to a chain rule. We pick a term, which we'll call u, and we'll set it equal to some part of this function. In this case, we'll use 5x plus 4, but you have to be smart in which part you pick. Then we have du over dx is equal to 5, of course, to get the derivative. And the smart part is that we can substitute this, we can multiply this to the original one, and convert this equation in terms of u. So this is, of course, u to the 7 dx. If we multiply this entire thing by du over dx, we get that this is equal to 5u to the 7 dx, du. And so now we simply need to integrate with respect to u. So, oh, sorry, we technically divide, but anyways, this is 1/5. Ignore that. Yep. And so in this case, we can get the integral of 1/5 u to the 7, which is equal to 1 over 40 u to the 8 plus c. Yeah. I don't know why the book says negative 1 over 40. I think they're a bit mad. Yeah, it's just 1 over 40. And so now that the integration is complete, we can substitute x back into where u is. So 1 over 40 times 5x plus 4 to the 8 plus c. So that is integration by substitution. Yeah. So that's pretty good. So now we can jump into some questions involving integration by substitution. So there's just a lot of questions. I'll do the odd ones. So the first one is the integral of 6x times 3x squared plus 4 to the 1/2 dx. And you could probably do this by sight, but let's not. So we go u is equal to 3x squared plus 4. So du over dx is equal to 6x. So we divide this by 6x. So we get the integral of u to the 1/2 du, which is equal to, is this 2/3 u to the 3/2, and so we can substitute it back in. So it's 2/3 times 3x squared minus 4 plus 4, sorry, to the 3/2. So this is the resulting integral plus c. Never forget your constant, plus c. Okay, on to the next one. The next one is we have integral of 1 minus 2x times e to the 2 plus x minus x squared dx. So I'm going to pick u as this one up here. So u is equal to 2 plus x minus x squared. Du over dx is equal to 1 minus 2x. So we can divide the original equation by 1 minus 2x. So then we get simply e to the u du. If we integrate e to the u du, we simply end up with e to the u du. E to the u. So this entire thing is simply equal to e to the 1 plus x minus x squared. Yeah. Okay, next one we have the integral of 3 to the x ln 3 sine 3 to the x dx. So I'm going to pick u is equal to 3 to the x. So du over dx is equal to ln 3 times 3 to the x. So if we substitute this back in, we actually divide, so those two cancel out. So we're left with the integral of sine u du, which is equal to negative cosine u, which is equal to negative cosine 3 to the x plus c. So yeah, that should be the answer. Next question, we have the integral of 2x times this, oh, it's lagging. Please no lag. Okay, 2x times x minus the square root of x minus 1 to the 1/2 dx. So what the question is, what to pick over here? I mean, I guess we could expand it, but I don't really feel like doing that. So what we do is we say u is equal to x minus 1, and du over dx is equal to 1. So this entire thing is equal to the integral of 2x times u to the 1/2 du. But the thing is, well, how do we express 2x in terms of u? And actually, well, we can simply do that by saying 2u plus 2 times u to the 1/2 du. Since 2x is equal to x minus 1 times 2 plus 2. I mean, I kind of don't want to do this. I want to do this without expanding it. Is there any way to do it without expanding it? And I guess not. I think we have to expand it. So then we can go here 2u to the 3/2 plus 2u to the 1/2 du. Or we can actually just take 2 out of this entirely, and so it's just u to the 3/2 plus u to the 1/2, which is equal to 2 times 2/5 u to the 5/2 plus 2/3 u to the 3/2. So this is equal to 4/5 u to the 5/2 plus 4/3 u to the 3/2. Yeah, so that is correct. Okay, on to the next one. And the next one is next one is, where is it? Can't see, 9. So we have the integral of x squared plus x secant squared x cubed minus 3/2 x squared dx. So of course we're going to pick this inner term, x cubed minus 3/2 x squared, as u. So we have du is equal to du over dx is equal to 3x squared minus 3x. So it's minus or plus? Interesting. Okay. Oh, okay. I think the textbooks made a mistake. I've just looked at the answer, and I think that, yeah, they've made a mistake, because this is supposed to be minus x. So if that's minus x, this entire thing is 1/3 secant squared u du, which is of course equal to 1/3 tangent u, which is equal to 1/3 of, was it x cubed minus 3x squared, tangent x cubed minus 3x squared plus c. Yeah. Can't draw, can't draw, can draw. Yeah, it's kind of annoying when they make these mistakes, not gonna lie. Anyways, on to the next one. We have 11. The square root of the integral of x times 1 minus x squared to the 1/2. dx, okay, so u is equal to 1 minus x squared. Du over dx is equal to negative 2x. So we have negative 1/2 u to the 1/2, I think. U to the 1/2 du. So this is equal to negative 1/3 u. This is to the 3/2, which is equal to negative 1/3 times 1 minus x squared to the 3/2. Yeah, plus c. Okay, yep, that's that. On to the next one. We have the integral of x squared over square root of 1 minus x dx. Okay, so we actually have to do this the hard way. So what we get is that u is equal to 1 minus x. So du over dx, of course, being negative 1. So we have this is equal to the integral of negative x squared over u to the 1/2 du. So what we get is that this is equal to the integral of, because u is 1 minus x. So u minus 1 is equal to negative x. So u minus 1, so this would be u minus 1 squared over u to the 1/2 du. So this is equal to the integral of negative u squared minus 2u plus 1 over u to the 1/2 du, which is equal to negative u to the 3/2 plus u plus 2u to the 1/2 minus u to the negative 1/2 du. So this is equal to negative 2/5 u to the 5/2 plus 4/3 u to the 3/2 minus 1/2 u to the 1/2 minus 2u to the 1/2 du. It would seem like this. And then should be equal to, is it just this? Negative 2/5 1 minus x to the 5/2 plus 4/3 1 minus x to the 3/2 minus 2 1 minus x to the 1/2. So not du anymore. What am I doing? But is it just this? 1 minus x to the 1/2 times, actually looks okay. Yeah, I think this is correct, actually. Okay, so that's cool. So that one's done. Actually, let's just check, because the book writes it a bit differently. It writes it, we have to factorize it, so that's okay. We have, let's multiply, so we get, what is this, negative 2 over 15 times 1 minus x to the 1/2. So if we do use that method of factorization, this would be excuse me, So this would be 3 times 1 minus x squared. 4/3 to 2 over 15. Yikes. So that's times 5 times 2. Minus 10, 1 minus x. Plus 15. So let's just check this part. This is equal to 3x squared, negative 3x squared. Oh, sorry, no. So this would be 3x squared. Minus 6x plus 3 minus 10 plus 10x plus 15. So this is equal to 3x squared plus 4x, 3 minus 10, 15, 5, 8. Yes, okay, so it's the correct answer, plus C, of course. Never forget R plus C, yeah. Yep, so that's the correct answer. On to the next one. And for the next one, we have the integral of sine x over 1 minus cosine x dx, which is actually, this one is u is equal to 1 minus cosine x, du over dx is equal to sine x. So we're good. So this is simply equal to the integral of 1 over u du. So this will be ln u, which is equal to ln 1 minus cosine x plus c. Yeah, so this one looks quite good. 1 minus cosine x plus c, yep. Then on to the final few questions. We have the integral of x over 3 minus x squared dx. X over 3 minus x squared. Interesting. So we have u is equal to 3 minus x. Du over dx is equal to negative 1. So we have the negative integral of... This doesn't really help though, it's just... Okay, 3 minus u over u. Integral of 3 minus u over u squared du. So this is negative, I mean this means we can expand it, so this is 9 over u squared minus 1, no, plus 1. No, it's not. This is 3 over u, so this is 9 over u squared, and then we have minus 6u, so minus 6 over u plus 1. Du. I guess that's what it allows us to do. So we have negative 9u to the negative 1 minus ln 6 ln u plus u. So we have 3 minus x plus, so wait, let's take the negative, so x minus 3 plus 6 ln 3 minus x plus 9 over x, 3 minus x. Is that it? Yeah. Oh, it's just that. Okay, cool. And then we have, I think it's our final one. So our final integral is 3 times x minus 4 all over 1 minus x squared dx, yeah. what do we want to do here? I guess du is equal to 1 minus x. Du over dx is equal to -1. So we have negative 3 times, well, we can convert this into x equals 1 minus u. What's x minus 4 in terms of u? X is equal to 1 minus u, so we have 1 minus u minus 4, so we have minus 3 minus u. All over u squared. Du, so this is equal to negative integral of -9 minus 3u all over u squared du, which is equal to negative integral of -9 over u squared minus 3 over u du. So this is equal to negative 9u to the -1, yeah, minus 3 ln u. So this is simply equal to 3 ln u minus 9u to the -1. So yeah. So of course we want to convert this back into x. So this is 3 ln 1 minus x minus 9 over 1 minus x plus c. So yeah, that's it. That is 10 integrals by substitution. I hope you enjoyed, and I hope to see you in the next speedrun. So see you then.